Very good morning, dear friends. Myself, Dr. Vikrant Sudhakar Palekar. I am working as an assistant professor in Gokhale Education Society's Arts, Commerce and Science College, Jawahar, Palghar. Welcome on the lecture series on the topic Mechanism of Organic Reaction. This particular topic is very important in order to understand the basic organic reaction and mechanism related with it. Mechanism is always helpful to understand the way in which organic reaction proceeds. This particular topic you have already studied in your earlier classes, and you have already studied the various mechanisms of the reactions. In this particular topic we are going to see the basic concepts related with the organic reaction. As we know that whenever we study the organic reactions, basically in organic reactions whatever the bonds are there, they have been broken and new bonds are being formed. The organic reactions basically we try to interpret in the form of the breaking of the bond and making of the bond. And in order to explain this particular process, the use of arrows is very important, as we know that the electrons are being utilized in the formation of bond. So the first process what we are going to see is the bond fission. Basically bond fission is nothing but breaking of the bond. So let us see what is a bond fission basically. As most of the chemical reactions involves the breaking of the existing chemical bonds and formation of new ones. So during the chemical reactions, the bonds are being broken which are already existed, and there is a formation of new bonds which are takes place. As we know that the chemical bonds can be broken in a multiple ways. There are different ways by these particular bonds are being broken. So if you see the breaking of the chemical bond, that is covalent bond, is often referred as a bond fission. So basically bond fission is nothing but the breaking of chemical bond, that is covalent bond, that is sigma bond or let us say pi bond. So basically this particular bond fission process is being takes place in the two different way. The first type is called as a homolytic fission and second type is called as a heterolytic fission. So these are the two types by which a covalent bond undergo breakdown process. So let us first see what is basically homolytic fission. In the homolytic fission, if you see, the breaking of the covalent bond takes place in such a way that each fragment get one of the shared electrons. As we see that whenever there is a chemical bond, there is a electron pair which is being placed in between the bond. So as we know that these particular electrons are being contributed by each of the atom by sharing process. So if we see the homolytic fission, homolytic means what? Symmetrical breaking. So in the homolytic fission there is a symmetrical breaking of the covalent bond which is being takes place, and as a result of that the two electrons which are being taken by individual atoms, and there occurs the formation of free radicals on every atom. So in the homolytic fission there is a formation of free radical takes place. So let us see example. If we take the bromine which is undergo homolytic fission in presence of light, then there is a formation of 2 Br free radical takes place. So the bonds which is being broken symmetrically and individual atom will get its electron, and this particular results into the formation of free radical. In the same manner we can write for the chlorine also and for other atoms also. Let us say for some, these are the homoatomic molecules. For heteroatomic molecules, let us see this particular example. This is a tertiary butyl bromide, and this particular bond between C and Br broken into symmetrical manner, and as a result of that you will get formation of Br radical and tertiary free radical. This is a tertiary butyl free radical formation takes place. So this is how the homolytic fission takes place, which result into the formation of very high energy unstable free radical species. Then we see heterolytic fission. In case of the heterolytic fission, the breaking of the covalent bond takes place in such a way so that one of the fragment will take away both the electrons. So heterolytic fashion takes place in an unsymmetrical way. The bond which is the atom which is being more electron withdrawing takes out both the electrons, and as a result of that there occurs the formation of cationic and anionic species, means positively charged species and negatively charged species formation takes place whenever there is a unsymmetrical or heterolytic fission takes place inside the breaking of the bond. Let us say A and B, and let us consider out of the A and B, B takes both the electrons which are contributed at the time of the sharing of the bond, and as a result of that B get one more extra electron, because at the time of bonding he contribute only one electron, but at the time of the breaking he take one more electron extra. So both the electrons are taken by the B minus, and as a result of that B will carry negative charge, that is it will anionic species, and this A plus will cationic species. In the vice versa, suppose A takes both the electrons, then A will carry negative charge and B will carry positive charge. So remember, in the case of the heterolytic fission there occur the formation of cationic and anionic species. For example, HCl, H plus and Cl minus. So HCl will break in the heterolytic fashion to give H plus ion and Cl minus ion. In case of the tertiary butyl bromide, again, as we know that bromine is more electron withdrawing as compared to the carbon. So Br will take out both the electrons during the heterolytic fission and it will carry negative charge, and this particular carbon will result into the formation of cation, that is tertiary carbocation. So C will carry positive charge and Br will carry negative charge. In the same manner we can write number of examples for heteroatomic species. This heterolytic fission generally takes place where the bonds are contributed by heteroatom, for example HCl, or there is a bond formation between carbon and halogen, carbon and oxygen. Now we are going to see a very important term which is being called as a transition state. As during the progress of the reaction there are intermediate species which are being formed. As we know that in order to study the mechanism of the reaction, basically what is mechanism? We ask the question, what do you mean by the mechanism of the reaction? So basically mechanism is nothing but route or the path followed by the chemical reaction to form the product is known as reaction mechanism. रिएक्शन जब होती है तो वो रिएक्शन का पाथ कैसे होता है ये एक्सप्लेन जिस मैनर से हम लोग करते हैं उसको हम लोग मैकेनिज्म बोलते हैं. Path followed by the reaction. As we say that reactant gets converted into product, but they do not directly get converted into product, but there are some intermediate species which are formed during the reaction, and with the help of the mechanism we can understood what is exactly the intermediate species which are being formed. So as we know that mechanism is stepwise description of the reaction in the transformation of reactants into products. Mechanism is the stepwise description. As we know that most of the organic reaction takes place in a one step or two steps. So for which we can understood, suppose for example there is a single step reaction. First the reactant gets converted into transition state. The transition state is the intermediate step which is being formed, and this particular transition state once the form that get converted into product. So in between the reactants and product there is a intermediate state which is being formed, that is being called as a transition state. So how can we define the transition state? So basically transition state is the transient. It is formed for very short time. It is being unstable combination of reactant and which do not have definite molecular structure. So basically transition state is very unstable, it is very high energy which is formed by the combination of reactants and they do not have definite molecular structure. So that is very important. If we see the example in which the transition state is formed, let us see the example of hydrolysis of methyl chloride by KOH in a one step reaction. Already you have studied in your earlier classes the number of reactions such as for example SN1 reaction or SN2 reactions where transition state are being formed. So we are going to take the same examples. Let us take methyl chloride. This is a methyl chloride. As we know that when it is hydrolyzed with the help of KOH, so there is a KOH being act as a nucleophile and as a result of that it will attack on the carbonyl carbon, and this is the intermediate step which is being formed by combination of reactants where this particular bond is being about to form and this particular bond is about to break. So this is the intermediate step where reactants are joined to one another. So it is very high energy step and it is being converted by breaking of this particular bond and you will get the formation of methyl alcohol. So this is a simple step. So we can explain this particular species in the bracket which is being shown, that is as a transition state, as it is very unstable which is formed by the combination of reactants. These two reactant combines. So this is the energy profile diagram, as already we know that here are the reactants, they are having some energy. Once they attack on one another, they will go to the formation of unstable transition state. You can see here the transition state is having very high energy where there is a combination of reactants takes place and very fastly they get converted into products. So this is a energy of activation which required to convert the reactants up to the transition state. So this is the energy profile diagram by which we can clearly say that this particular point is the transition state having high energy. Now we are going to see the important term that is being called as an intermediate. So in a two-step reaction, basically if we see the reactants for first combines to form a transition state 1 and this particular transition state 1 then converted into intermediate, and this intermediate in the second step again get converted into transition state number 2 and then transition step 2 is being converted into product. So basically intermediate formation been occurred in a two-step reaction. So during the intermediate formation there are two transition states which are being formed. So if you want to define what are the intermediate, they are short-lived species formed during the course of the reaction and they have definite molecular structure and shape. So remember, this is a very important property because transition state do not have definite shape, but intermediate do have the definite molecular structure and shape. What are the examples of intermediate? Carbocation, carbanion or free radical which are formed during the reaction, which are being defined as a intermediate. So compared to transition state, intermediates have less energy and hence they are more stable. So intermediates are being more stable because they are having less energy as compared to the transition state. So intermediate may be isolated under special conditions. So intermediate can be isolated and they can be identified in a very special conditions. If we maintain, then we can isolate them. If you see the examples during the hydrolysis of tertiary butyl bromide by KOH in a two-step reaction, already you have studied this particular reaction. This is a SN1 reaction. So in SN1 reaction, tertiary butyl bromide, as we know that this is a tertiary carbocation, tertiary carbon, it is being attached to three alkyl groups, that is methyl groups and bromine. So this particular bond is get dissociate and it is about to break in the first step, that is being called as a transition state 1, and very fastly this particular bond get broken and you will get the formation of intermediate carbocation, and this particular carbocation is tertiary and it is being called as a intermediate. intermediates is a carbocation species, and in step 2 this particular carbocation species then attacked by the nucleophile. So, a nucleophile attack in the second step, and as a result of that this particular bond is about to form in the transition state, and very fastly it is being formed, and you will get the formation of tertiary butyl alcohol. Here you will get the formation of OH in the second step. So, basically if you see the hydrolysis of tertiary butyl bromide by KOH gives the formation of tertiary butyl alcohol. So, here occurs the formation of carbocation, and carbocation is the intermediate species. If we see the energy profile diagram, again we can explain. This is a transition state 1, this is a transition state 2, and where is the intermediate? Here is the intermediate. So, you can see that it is having lesser energy as compared to the transition state. As compared to both the transition state, it is having lesser energy. So, intermediate, here is the carbocation is being formed, and then it is being converted into product. So, we can clearly try to understand what is the transition state and what is the intermediate state. So, if we see what is the difference between transition state and intermediate. Transition state do not have definite molecular species, it is a definite molecular species. Transition state is always considered as an imaginary structure showing loose combination of reactants, but intermediate do have the definite structure and shape. Whatever the carbocation is being formed, whatever the carbanions or free radical is being formed, they are having definite structure and shape. Transition state has high energy, intermediate has less energy. There is no proof for its existence. There is no proof for the existence of transition state. It is therefore it is said that it is a imaginary structure. So, there is a existence can be detected. It cannot be isolated. This is a very important difference. It cannot be isolated, hence it can be isolated in a special condition. Transition state is formed in all the reactions, and it can be formed only in a multi-step reaction. Remember, transition state is formed in every reaction, whether it is a 1 step, 2 step, 3 step or multi-step, but intermediate is formed only in a multi-step reaction. So, more than 2, 3, 4 steps the intermediates are being formed. So, these are the basic difference which we can say in terms of the transition state and intermediate state. So, hope so you have understood the basic concepts related with the mechanism of organic reaction. What is the mechanism, how the mechanism is important to in order to understand the bond fission process, what is transition state, what is intermediate state. Go through the basic concepts. We will see in the next with some another topics from in the topic from the mechanism of organic reaction. Till then, take care. Thank you very much.